Welcome everybody. Today we're going to be talking about graphing radical functions. Okay, so a radical again is like a square root. It could also be a cubed root or any type of root. We're going to be focusing on square root equations, but these are still radical equations. Okay, so let's kind of get into this. First off, we're going to talk about parent graphs. You're probably familiar with the quadratic. So this first one is a quadratic. We know it's a quadratic because it's x squared. Okay, and we want to graph that. So one way we could do it is by filling in this table. I already filled in some x values that would be appropriate, that would fit on the graph, and then we could find the y values and plot those points. So if we plug in -3, so -3 squared, that would just give us 9. And we could finish this, fill in the table, and we can plot those points. So we've got -3, 9, -2, 4, -1, 1, 0, 1, 1, 2, 4, and 3, 9. We'll connect those dots. And this should be a familiar shape. We did this a lot last year when we did graphing quadratics in secondary math 1. All right, so let's kind of do something similar for this radical function. Again, we want to come up with some nice x values. So something that we could do is we could try -1. But if we were to plug -1, we would get an imaginary number, which is nothing wrong with imaginary numbers, but if we're going to graph it on an xy plane, it wouldn't go there, right? We would need a different type of graph system, okay? So this doesn't really work. We could do 0. The square root of 0 is just 0. And maybe think about a couple other numbers that would be really nice that you can square root. So something like 1, 4, and 9. Those are all great numbers that you can square root. Okay, we could also do any other number like 2. We'd end up getting the square root of 2. And there's nothing wrong with that, but we would get some sort of decimal and would have to round. So these are nice numbers because they are exact and we don't have to round. So let's see if we can plot those points. So 0, 0, 1, 1, 4, 2, and 9, 3. We'll connect those dots. Again, when we look at this, we can't go any further on the left. Anything that's less than 0 would end up giving us a negative in our square root. But we can keep going in the right, going to the right. That never stops. Okay, you can plug in any positive value for x, and we would still be fine. Okay, so look at these two graphs, and let's maybe talk about some of the things we notice that are the same or different. Just some of the things that students have mentioned in the past is the radical function on the right looks like half of a parabola. It has the same sort of pattern, but with a quadratic, the growth going up goes 1, 3, 5, and for a radical function, it goes to the right 1, 3, 5. So it's like these two numbers kind of switch. If we look at these here we have 3, 9. Here we have 9, 3. Here we have 2, 4. Here we have 4, 2. So it like switches those numbers. Okay. Okay, and then let's see what else. I think that's pretty much it. I have this kind of filled in over here. You're welcome to write that down on your notes if you would like to, okay? But basically it's the same thing that we just talked about, okay? We also need to talk about domain and range. So domain, again, is all possible x values. For our quadratic, it would go from -infinity to infinity. this parabola gets wider and wider and wider forever as it gets higher, okay? Range is how low and how high, and the order matters, so low would be 0, and how high, it doesn't stop, it goes to infinity. So one thing we need to remember that if we include the number, we want to use a bracket. So 0 is one of our y values, so we'd want to use a bracket. We don't use a bracket with infinity because it's not a number, okay? It's an idea that those numbers never stop, okay? Domain for the radical function, again, left to right. From the left, it's 0, and to the right, it never stops. It goes to positive infinity. As we go low to high for the range, it would go from 0 to infinity as well. Okay, but realize that it's going vertical, like low to high, and the domain is going from left to right. Okay, kind of the difference. Even though we write these exactly the same, they're saying different things. Okay? All right. So let's talk about the form for a radical function. Before we do that, let's talk about the quadratic. Since we're graphing, vertex form is the way to go. It's called the transformational form. Okay, well, I hope I said that right. It's really good for graphing. Okay, H and K gives us the vertex, and A either reflects it over the x-axis, and it also vertically stretched or compresses. If you remember, we did that last year in our graphing unit. Okay, the thing about the radical form for transforming, okay, is very similar. H and K, we don't call it the vertex, it's just our starting point. But A does the same thing. It either reflects it over the x-axis or it stretches it. And we'll do some examples of that in a little bit. So as long as you can find your starting point, and then we could use like that pattern that we talked about, then we should be good to go to graph any of these functions. So I have these tables. I was thinking of maybe filling in the tables, but I think it's better just to maybe use those transformations instead. So I will still ask you to maybe write down your starting point. Sometimes it looks different because either your H or your K is missing. So for this one, K is missing. Our starting point would be 1, 0. So just a reminder, when we're trying to find our X, what we're really doing is trying to figure out what X needs to be to make the inside, the radicand, 0. So X has to be 1. And if we plug in 1, we end up getting, this whole thing cancels away, and we end up getting y equals 0. And that's our K. All right? So that would be our starting point. We will plot that. And then, again, our pattern is we will go up 1 over 1, up 1 over 3, up 1 over 5, which doesn't fit. Connect those dots, put an arrow showing that it keeps going to the right, and we're set. Okay? So again, the number inside that -1, again, its H is 1, meaning we're moving it to the right 1. Okay, let's maybe look at this one. Okay, so here again we would have a starting point of -1, 0. So it's going to move that same graph, but to the left 1. So 1, 3, and I think here we could actually do our 5. Okay, so every time here it's just going up 1 because A is 1. Okay, if A is not 1, then it's going to be different, and we'll do an example of that in a little bit. Okay, if we look at this example, again, if it's helpful, we could write it so it looks like all of the others. If that's helpful, our starting point would be 0, comma, -1. So we'll plot that 0, -1, and we'll go up 1 over 1, up 1 over 3, up 1 over 5. Again, that we don't need to plot it. Okay, and put a little arrow, and we're good. For this one, our starting point would be 0, comma, 1. And that's going to move it up 1. But again, we'll have that same pattern. Okay, so K moves it up and down. H moves it left and right, just like we did for quadratics before. Okay, we will maybe skip those domains and range. We'll do some other examples of that in the future. Okay, so here's some just important ideas. Some of these things are really good if you're trying to do a table instead. Just thinking that we cannot have negatives inside of our roots. And if you want to do a table, you'd want to put in values that are nice to square root. Okay, but if you just kind of do it by using the starting point and the pattern, then that's just a different way to do it and is just as valid. Okay. One thing that we can notice, and we'll talk about this more, is our domain is always our h, like what's inside that square root, and range we always use the k. Okay, those are the things that we use when we do the domain. So we'll look into that a little bit more. So here's some quicker, some other problems that might be a little similar to what you'll see on your homework. Again, I'd ask you to maybe start by writing down your starting point. Again, we could put that plus 0, or what the k is, and we could put it there. We'll plot that, so -3 in the x and 0 in the y. And then again, we're using that same pattern, 1, 3, 5, going across. A little wiggly. Okay. Our domain is left to right, so it goes from -3 to infinity, and the range goes from 0 to infinity. So that's what I was kind of saying, is that your h and your k are the h's and the numbers that we use in those range, domain and range. Okay, but I would still maybe do a sketch of this or graph it if it asks you to graph, or if they're not asking us to graph, then I would just still sketch it anyways, draw it anyways. Okay. All right, here's another example. Our starting point would be 0, not -4. It'd be +4. So that would be right here. And again, we have that same pattern. 9, there we are. And then our domain would go from 0 to infinity. And range goes from 4 to infinity. Okay, so again, we can kind of see that 0, 0, 4, 4. Okay, so it's all based off of that starting point when we do our domain and range. All right, let's look at something, kind of combine these two things together. Our starting point would be 1, comma, -2. So we would plot that. And then we have that same pattern, up 1 over 1, up 1 over 3, up 1 over 5. Okay, the domain here would go from 1 to infinity. Sorry, that should have a bracket. And then the range should go from -2 to infinity. All right, so here's something a little different. We talked about it briefly, but if A is negative, that means that it's being reflected over the x-axis. That means it's going to look something like this instead of something like that. Okay, so if we're still going to write down our starting point would be 4, comma 1. That doesn't change at all. 4, 1. But it's going to go down 1 over 1, down 1 over 3, down 1 over 5. Okay. So I didn't get that one very good. Again, you don't ever have to put points outside of your graph. Sometimes I do it just so that it kind of looks a little better sometimes, but all right. So again, a negative is going to reflect over the x-axis. It's going to go down instead. Okay. All right. Our domain here might change a little bit, or range, probably our range. Okay. So again, we're still going to go from 4 to infinity for the domain, but the range, again, we're going low to high. So now this radical, as we go along, it gets lower and lower. So it's going to go from negative infinity all the way to 1, and it's going to stop. It doesn't go any higher than that. So here it's kind of swapped. Now the infinity goes first. The negative infinity goes first. All right. All right, now we have something, we haven't seen this before, even last year, is this, okay? So if you have a negative inside, then this is going to reflect over the y-axis. So if I have a little room here, if we had a starting point, normally it would go like this, but instead it's going to reflect it to go the opposite direction. So if this is negative, then it's going to go that, I guess say that again, it's just going to the left instead of to the right. Okay, so we'll start by writing down our starting point. So that doesn't change at all. We don't want to distribute this negative because then it's not in the right form. So we want to keep it how it is, and we would have 6, 2. We'd plot that 6, 2, but then instead of going up 1 and then over to the right, we're going to go up 1 over to the left. And up 1 over 3, up 1 over 5, up 1 over 7 would be our next one, and it actually fits. So why don't we put it there? Okay. All right, domain, so it's going to, from the left, it goes to negative infinity and stops at 6. And then range goes from 2 and keeps getting higher and higher forever. All right, for F, we have something else that's a little different. Here, A is 2. So if you remember, when A is not 1, it's either going to either stretch or compress. I think all the examples we have here are going to be stretching. So that means it's, instead of going up 1 every time, it's going to go up 2 every time. So our starting point would be 0, 0. Keep that with red. But then instead of going up 1 over 1, up 1 over 3, and up 1 over 5, it's going to go up 2 over 1, up 2 over 3, up 2 over 5. Okay? So you don't need to do those first points that we did. I was just trying to give you an example. So this one, I did dotted lines. That's what it would be if A was 1. And we're just doubling all your numbers. Okay, so stretched by a factor of 2. All right, I'll just erase that just to not have it be confusing. All right, our domain goes from, we've already done this one, 0 to infinity and 0 to infinity. All right, here we go. This kind of brings it all together, these last two problems. Our starting point would be 2, negative 1. So we'll plot that. And then here, what does this do? It means it's going to go down by 3. So it's going to go down 3 over 1, down 3 over 3, down 3 over 5. And just connect those dots. Put a little arrow on it. and we're good to go. Our last example isn't in the correct form. So the correct form, this is our k. It needs to be over here instead, just so that it looks like all the others. Some people might accidentally think that's our a because it's in front, but it's just not in the right form. So our starting point would be -3 comma -2, and -3 and -2, and then our pattern, again, it's not being reflected, it's not being stretched or anything, so it's just up 1 over 1, up 1 over 3, up 1 over 5. And we're good. All right, so here, if you want to write this down, I think it would be a great idea. This kind of brings it all together. So A can stretch or compress. Again, I think most of the examples you'll have, it's just going to stretch. So you're going to go up 2 or up 3 every time. Okay, and if it's negative, if A is negative, it's going to make it reflect over the x-axis. In effect, it's just going to go down every time. Okay, if B is there, I think most of the time it's just going to be either positive or negative. If it's positive, it's just normal. If it's negative, again, it's going to go to the left every time. Okay, it's being reflected over that y-axis, so it's going to look something like this instead. All right, and then h and k, again, is your starting point, and we'll do that every single time. Okay, so couple quick questions here. Can the domain of a square root function, or like a radical function, using a square root, include negative values? And the second question asks, can you have negatives in the range? So yes, we can. We had an example. If we did the domain here, our domain goes from -3, sorry, that should have a bracket, -3 to infinity, and the range here goes from -2 to infinity. So here we have an examples where we have negative values in our range and domain. That's just totally fine. Where we run into issues is if we plugged in a negative, or plugged in something for x and it gave you a negative, right? So that's why these functions stop. Anything over here, if we plugged in any of these x values, we would end up getting imaginaries. Okay. All right, and then the last thing, I meant to delete those, so just ignore that for a second. Okay, the last thing I'm going to ask you to do is to write down the equation from a graph. So you're kind of going the opposite direction. We need to know h and k. So for this one, it would be 1 comma -2. And our form, again, we have that just up here. We need the h and k so we can plug it in. So we'll have square root of x minus h. So x minus h. Wait, let me say that again. X minus 1, and then minus 2. So again, just how when we take that out, we end up having like the opposite sign. And then this is not being reflected or stretched in any way. So this would just be our final answer here. So here's an example. Our starting point is -2, 2. So when we put it into our equation, we'll have x plus 2 and then plus 2. And this time it's reflected over the x-axis, so that means that the negative has to be outside. So a is a -1. And then our last example here, our starting point would be 3 comma 2. So when we write down our equation, we'll have x minus 3 and then plus 2. And it's being reflected over the the y-axis. It's going to the left. So that means that we have to have our b is a negative. So that would be our equation. Okay. The last thing I wanted to talk about is number 6 on your homework. It looks something like this. Okay, and I'm asking you to find the domain and the range. So if you have an equation and you don't have the graph, and I want you to find the domain and range, sometimes it's helpful to come up with your starting point, because that's what we use, those numbers, for our domain and range. So again, our starting point, our h, is always what makes this 0. So if you remember, we've done that lots of times. We could set that equal to 0 and we would solve. So we could subtract 2 and divide by 3. And that would be our x for our starting point. Our y for our starting point is our k, and that would be like a +0 out there. So if we plot that, roughly, it'd be about right there on that graph, and it's not being reflected or stretched or anything, so it's just going to do something like this. So now it's a little easier to write down your domain. So domain goes from negative, what is it? I got that back. Negative 2/3, comma, infinity. Sorry, I have, this be a bracket, Mr. Warner. Okay, and then the range goes from 0 to infinity. All right. Another way another student told, or another teacher showed me this is kind of cool, that if we want to write it, we can also write this. We can factor out a 3. And we would end up getting x plus 2/3. So here we would end up getting h is negative 2/3. So that's another way to kind of do the same thing. And it would be, that would just tell us that it's horizontally stretched, which we haven't really talked about that, but it's not really important for coming up with your domain and range. All right. Okay, so I think that's about it. If you have any questions, please let me know, and good luck.